Hello, hello! It's been a while, and today I've got something a little bit different. This is a automotive battery tester for checking lead acid batteries. And what's happening with this one is the clamp, well, this clamp's been replaced before, and this one's had the wire resoldered on, and what it's doing, if I connect it up, is it's telling us to check the clamps, which is quite interesting because they all seem fairly well attached. But here we are. Check clamps. Yeah, as we can see, our clamps are firmly attached there. So we'll crack it open and see if we can figure out why it's stopping there. Now if we have a closer look at the clamp, we can see that you can see where they've re-soldered the wire. It's obviously broken loose, and they've reattached that. And I'd just like to point out an interesting construction on these battery testers is a double jaw system. So you can see the outer metal connection there, and on the inside you can see the secondary jaw, and that's actually what the wire connects to. So and I've checked the resistance to there. It's normally connected via the rivet there, I think, and well, the rivet at least isolates. You can see an isolating washer there that keeps it separate from the outer metal jaw, and the resistance is 0 to the center jaw, inside jaw, so the solder work has connected, even though it does look a little bit flimsy and you can kind of move it if you poke it a bit. So it could do to be better. This one has been replaced with a completely different clip at some point, which may be part of the issue because it doesn't have the secondary jaw on the inside, so the entire connection's made with the outer jaw. So we'll follow the leads back inside the unit and see if that's what's going to be an issue there. Okay, I've flipped it over, and we'll start by having a look under here, and it has a 9-volt battery, so we'll whip that out first. And it looks like a screw in each corner to get that Now, where I work, we happen to have a battery tester there as well, because we sell batteries, and it's just part of the deal, so that we can check them to see if they're all right before we yay or nay a new one, if someone's saying that their one's dead, because there's a few things that cause battery failure or appear to be the battery when it's not the battery. But that's why I'm aware of the double jaw on those. I've been able to have a good look at the one at work while I've been there. So let's see if we can separate this case. What's involved there? It's slowly coming. It might be stuck on the end connection there. So hold that down, lift that up. No. Okay, what have we got? There's not a screw in the middle or under there. It's possibly the battery terminals need to slide through. Or maybe not. Just keep lifting and have a look around the edge there. Ah, it looks like the whole board's going to come away from the front. Yeah, it looks like the board might stay in the back section. Okay, one moment. Okay, this is interesting. It looks like the battery terminals are soldered on and then pushed through the case and folded over at the end, because I've just folded those back a bit, and it looks like it's going to slide off. Now, there it goes. You can see them pulling through the case. What a pain in the ass design. And there we have it. Right. Gosh, you wouldn't want to have to open this too many times. That'd snap in half pretty soon. Now, what have we got here? Oh yeah, proprietary IC. They've gone and scratched the number off to hide their design. We can't have anyone copying it, can we? 10 watt and what do we got there? 0R1, possibly 0.1 ohm. Now that'll be the test load, and it's only activated very briefly when it does conduct the test. Now immediately what I notice here is here's where the leads come in from our alligator clips there. Bring that up, and you can see them come in. You can see each one is actually a pair. When we come down to here, the pairs split there and there, and there's a fairly hefty copper track to the outside ones there, and we've got looks like possibly some kind of, oh no, it's a diode. There's a diode there with outside to in, what are we, anode to cathode in the center, and over here we have a what is that, an F1010E, and if I have to guess, I would say that was a FET that would turn on briefly, drop the battery across the load resistor, and at that point the internal the circuitry here, the microcontroller, takes a measurement, and understand they have neat little lookup tables that they can refer to, volt drop, or actually they may even induce a signal through it. I think I read somewhere they pass a frequency through the battery and measure the outcome of that, and that can tell how much sulfation is on the plates, and actually give quite an accurate reading as to the capacity of the battery, or the CCA, cold cranking amps rating. Yeah, quite a smart little device, and it's done in a split second. They're able to test that. I mean, you can get your old load testers with a big carbon pile and it drops sort of 300 or 400 amps through it, but you're not going to be able to do that in this, especially when that's not even heat sunk. That's quite interesting. So very, very split second test period, and it saves burning up the resistor as well. So back to the leads there, you can see we've got separate leads. I wonder if we can get this board out. It has got an LCD on the back and a couple of buttons there. But I would hazard a guess, and I'd safe to say it'd be a fairly good guess, that the outside, one of the leads should be connected to the outside jaw. One of the leads should be connected to the inside jaw, and I'm not too sure which one of those jaws would normally be the test or the monitor, because I'd say one of them would be for monitoring the battery voltage while the heavy current is passed through the other one. And I would suggest it's entirely possible that the heavy currents pass through the center jaw there. There we go, that's handy. So on the left two pins, it's got positive J1 I and positive J1V, negative J4V, negative J4I. So that's a positive and negative, but as for which one goes where, if we could follow, I'm just following, that trace goes up to this resistor, through that resistor into there, that trace runs off under there. I'm going to call that the signal, probably a signal line. That's our positive J1L which also actually runs through here. Alright, and that goes through the load resistor. And the J1V comes up under there, runs through all these surface mount, a few of these surface mount resistors I should say, and through a whole bunch of diodes. Okay, that's probably our sensing circuit there. So J1V is our sensing circuit and J1I is our main test current circuit, because it does come through the resistor. And we've got V and I suppose I is current, yeah, and V is voltage sensing, V for voltage sensing. So I guess if they put these clamps on backwards, maybe it's a polarity error message. We'll follow that back to the clamp and make sure that positive's on the red clamp there. Okay, so there's our positive J1. We get a good connection there. He's sliding off. Okay, that's good. And make sure that we don't have connection through to this side as well. Oh, what was that? No? Okay, good. Just something charging up there. We've got connection through to positive JV and nothing on there, and negative JV. We've got connection through to the outer jaw, but not the inner jaw. And JVI is the inner jaw, but not the outer jaw. Okay, so that kind of reinforces what I thought, because JI, so J4I, or J1I and J4I, the J4I, I would stand for current, and that goes to the inner jaw, and the inner jaw is I think is it's a different metal, I'll give it that. It's not as shiny, it may be brass, but I'm not 100% sure. It's quite dirty, but it's a different metal, and I have every theory that that's probably a test load jaw. It would bite into the terminal a bit better, looking at the teeth on that, so it would give a better reading, and to be perfectly honest, with the one at work, if it doesn't have a good connection, when it does the test, you can actually see a spark off that center jaw if it isn't connecting properly because of the current that flows at the time, and I have seen that. So that makes sense. So what's actually happened is they've replaced this jaw and they've joined both wires together, and the unit's not happy with that because it's unable to. It can obviously see that that's connected. Both leads are connected, and won't conduct the test until they separate. And yeah, it must be to do with how they sense the voltage, and if they're both joined together, they'll get inaccurate readings and whatnot. So what we need to do now is figure out a way to modify this clamp so that it has two separate jaws. Well, a quick phone call to my local battery supplier, and they actually told me they had a few dead units lying around that I could go and rob for parts, which is very nice of them. And Now I picked up this one. It's got a really good set of test leads on it. They almost look like they haven't been used much at all. And this unit is apparently faulty, and sure enough, when I go to perform the test, it comes up with this error message. So since this is an older unit, it's got a LED 7-segment displays in it, and just a sort of a test okay, no good indication, and lights down there. The other unit there has an LCD on it and shows more information. It's a more advanced, so there's no point trying to resurrect this. I'll just pinch the leads off it, and we'll be able to see perhaps too what's wrong with this one. Okay, we're inside the donor unit, and the wiring is exactly the same. Very similar construction. We've got a FET and a double diode junction there. That must be our test resistor. Not quite as beefy as the other one, but that's fine. And yeah, nothing blowing its guts out or anything obvious like that. So I guess we could do a couple of basic checks and see if one of the semiconductors is popped there, and what do we got there? So if we go from outside to center, that's the way this one works. What are we getting there? Yeah, it's not exactly what I'd call a diode junction, but I mean they're both the same, and there's other things in circuit as well. Let's just look at the original one as a comparison. See what that one is, because we know this works. Yeah, it's the same, so that's alright. And the FET, what do we got on the FET? Nothing. Oh yeah, half a volt there with it. Base charge, maybe not. Well, it's not shorted, so that's a good sign. And there's another transistor down there, which could do anything. Looks alright. Oh well, I'll leave it at that. They're the main semis in there, and this isn't a repair video for a donor. So what I'll do is I'll rob the wiring off here and transplant it straight into the other one. But before I do, just to make sure, I will check which jaw each of the leads goes to, because we don't want to just go in blindly and end up getting it backwards. So the outer jaw of positive, I said, would be the voltage sensing. If we go to the voltage pin, there we have it. Look at that. So if we go to the outer jaw to the other one, there's no connection there, which is what we expect. And we go to the center jaw, there's our connection. So the center jaw does all of the load as thought. And if we go here, we've got the center jaw on negative there, and the outer jaw there. Marvellous. Let's rip it out. So it's got some fairly hefty wiring, so I've just cranked up the temperature a bit on the old iron, because it's only a small iron, and it's certainly not the biggest tip there. And see how we go. Wound it up to 350 degrees. Oh yeah, here we go. Very slowly. Get some heat into that joint. Actually, that can move. Slide that guide away, and should be able to attack these individually. Ooh. course, getting a lot of heat into them, the insulation kind of comes with it, so we don't really want to do that. We don't need any shorts up at the end. That's better. That's better. Here's one. And the other one. As you can see there, the insulation started to melt back, but I think that'll be alright. The other one's fine. Yeah, that's not going to be an issue at all. And that one came out a bit easier. Very good indeed. Now these wires are twin core joined together, so what I've done is I've peeled them apart, and that will make it easier to get them out, because you can just pull on one wire at a time instead of trying to tug on both of them and be limited by the fact that the other half is still soldered in. So makes it a lot easier. Now I won't bother clearing the holes out of solder because it would be handy to retain the wire as it goes back through. So I'm just going to heat it up and feed that back through nice and gently, so find its way through. It's getting stuck. There it goes. And then once it's in, I can go through with some fresh solder and touch it up so that it can be supported in the hole by the fact that it's partially connected to its mate, and make life a little bit easier for me. And of course we want to double check our work and make sure that the wires did end up back at the right position, and we have our positive current connection, which is center pin and not the outer, and the outer to the negative, sorry, not the negative, the voltage sensing pin, and then our negative connection. We have our voltage sensing again, and not the center, and our center connection to the current sensing and not the outer. So looking good so far. And now the big test. I've got my dirty old car battery here, which has some life left in it, and positive on the left there, and oh, before I get too carried away, I better put the 9-volt back in there. It might not work otherwise. Right, and our negative. Check clamps. Well, doesn't that rip your undies? Why? No, it doesn't want to work. Like I haven't put the screws back in. Now, interesting to note, I just had a look, and if I put go diode test here, and I thought I'd see if there's any reverse polarity protection, and certainly on the voltage sensing side I'm getting no reading, but if I go into the current sense side, I'm getting a forward drop there, which I don't get on the other device. I check that. If we go in reverse, there's nothing there. Yeah, because of that, with having positive and negative as they are, there's going to be forward biasing of something in there, and we're going to get current flow, and that doesn't sound right to me. Let's look a bit further. Also, since we're going to be opening this a couple more times, I think, these posts here sit inside the PCB, and the PCB is drilled out. It's a very tight fit, so you can actually pry off the front from the posts at the end and not need to bend the terminals all the time for the 9-volt battery, which were a bit fiddly to feed back in. The best bet would be to desolder them from here, so that you can remove the board and just leave those terminals in the back cover. Prolong the life of the terminals, make life a bit easier, perhaps getting it in and out too. You're not going to believe this. Look what I found. Whip out my special macro lens just for this, but there's the IC with its numbers scraped off. And they've obviously used a power tool for this, and see if you can notice what I noticed. They've slipped off the edge, and on that top, if I put it around this way, it's the top row of pins, they've gone and ground away half the leads right along. They've slipped off, and there must have been I would say a rotating tool like a Dremel, and they've gone and just ground away the corners of all the legs there at the top edge. That is just incredible. Careless and poor quality there, and I don't know how that passed QC inspection, but far out the lengths they go to protect what they're using. And I mean, it'll be the code inside that does all the magic anyway. They don't need to hide what sort of chip it is, and they go and damage the bloody thing in their efforts. Impressive, huh? Now I've been probing around with the meter and checking the diodes and whatnot. We've got a whole string of diodes along here. There's another diode there. This is our 5-volt voltage regulator, and a couple of diodes in behind there. These are actually optocouplers, so they must be isolating part of it for their readings for some reason. And yeah, our FET and diode there which all seem okay. Now what I've noticed, this diode down here, it's not marked D with a number like the rest of them, it's marked SD, but it does tend to measure short circuit. So I'm going to desolder that one and just check it out of circuit, make sure, but that comes off our 5-volt regulator and feeds over here. So I would imagine that should be more like a diode than SD. I suppose it could be Schottky diode, but it's still, the value I'm getting off it is far too low. It's very close to pretty much being a short, so we'll pull that off and double check it. Okay, just having tested that diode, and that checks out of circuit. It is a Schottky. It's got quite a low forward bias. I think it was about 0.2 compared to your normal diode junction of about 0.5 volt. So kind of coming to the end of all the sort of passives, the or the diodes, and I checked a few resistors and make sure they were all right. And there's really not a lot left on here other than this IC here, which is a inverting hex Schmitt trigger. So it's I think it's got 6 of them, and yeah, six hex Schmitt inverters. So you put 5 volts in one pin, you get 0 out. You ground that pin, you get 5 volts out. So it's just inverting logic there. There's another IC up the back that I haven't yet looked into, and then there's this little one down here, and what that actually is two FETs in one package. It's got a N channel and a P channel. Now I'll just show you the data sheet there. Okay, and what we're looking at is on the left is an 8-pin package, and on the left side is the N channel FET, and on the right side is the P channel FET. This IC number is STM8405, and along the bottom pins there, from left to right is pin 1 through 4. We've got source 1, gate 1, source 2, gate 2, and along the top two drain 1 are the top two left, and the top two right ones are drain 2. Now when I make a measurement in circuit between source 2 and drain 2, is showing up as a dead short. So I've shorted out the gate to try and remove any residual charge that might be on there turning the gate on. I'm pretty sure that's right. So the next step is to take it out of circuit and make absolutely sure that that is shorted, but certainly the reading I'm getting in circuit is that it is. And I don't quite yet know where that's connected to or what it does, but yeah, we'll pop that out and double check it. Okay, so I'll be probing from pin 3 that you would have seen on the data sheet, which is our source 2, and over to the drain pins. And what do you know? No short. That's interesting. So maybe this device is actually okay. Maybe there's a short on the board there, because I mean, why would you join the drain and the source together on the main board when it's supposed to be a switch that's supposed to be able to be turned off and on by another signal? So here's our board, and I'm going to measure from source 2 again, which was there, and over to our drain. And look, our short has magically disappeared. I hate that. On a good note, it means that our IC is okay, but it doesn't mean we're any closer to finding the cause of the fault. Nah. She's all hunky-dory, as they say. Okay, so in the end I went back to the place I got the dead unit for scrap from, and I went and see if they had a model the same, and I was lucky enough that they did. Exactly the same with the LCD on it, and I thought, well, at first I thought maybe the CPU was a bit upset, so I actually swapped that out, that IC there, that one there. I actually swapped it over just to see if it would make any difference, and it made no difference at all. It was a bit of a long shot, but I thought, hell, while I've got it, I may as well. So I thought a little bit more about it, which I probably should have done in the first place, and thinking, why would it be asking me to check the clamps? It's most likely because it's comparing a voltage, and it's probably comparing a voltage between the test point and the because you remember I said the clamp was in two pieces there. You can see the double jaw, so it's comparing the voltage between the outside and the inside of the jaw, and then I thought about how it might be doing that, and I'd been looking along here for some time, and it does appear to be some sort of resistor divider network of some sort. So yeah, anyway, I don't have a schematic diagram of this thing, but I have the next best thing, the donor board. So I just went along comparing values, because this one wasn't throwing the error. It does have some acid damage down there. It's been splashed with acid at some point, but it's also got a blown trace off the back of that FET there. It's burned out and the FET's pretty toasted, so it's had a hard life. But I went along measuring the resistors along the top row there, up the left hand side of those diodes, until I came across a value that didn't match, and that ended up being that little resistor right there. That one right there, which according to the silk screen is where are we? 1, 2, 3, fourth one down. So R5 is the designation there, which was 120 k ohms. In parallel with all these others, as it's set up in there, it should have measured 65 k ohms across it, but it was actually measuring something different. And when I removed this from circuit, it was actually open. It had gone very high value. So I swapped it over, and that seems to have been the golden ticket. We should get that off. Okay. So now, when I connect it up to my battery, dummy battery, there we go. No longer need to test the clamps, and we can give the battery a test. Now I know this battery is a dud. It's rated at 370 CCA. If we test that, it comes up as bad because it's only testing as having 206 CCA capacity. That'll be due to sulfation on the plates. You can cycle through the test results after that, and of course if I do the test again and knock that value down, because this is just telling it a value I expect it to be, if I knock that right down to below 200 or about 200, it'll say it passes because it's testing within the spec that I give it. So yeah. Yeah, so I don't know, a few things I could have learnt from this, I suppose, is excuse me, be patient. Try and think it through logically. Without a schematic, you're flying blind in a sort of a way, but the layout of the board did tend to suggest, you know, that's a resistor divider network there. It must be dropping down through those diodes to the voltage to some kind of reference level for the IC, and that reference level was not what it expected because that resistor was out, and hence why it was saying to check the clamps. Out of curiosity, what if I just put half a clamp on? I wonder if that will work. If I just put the negative on completely and then just touch the outside of the positive, there you go, check clamps. So what if I just touch the inside of the positive clamp and not the outside? Is that going to work? It's not going to work at all, so that's interesting. It does get the power off the center connection as well for the rest of the circuit. Well, I hope you enjoyed that one. I kind of learned a little bit, and you got to see inside a battery tester. This unit, model number BT002. BT001 had the 7 segment display instead of the LCD. But Yeah, they're sold under varying brands, I believe, but they all have the same guts, all do the same job. Here we go, version 15, 28th of the 11th 2006. Yeah, alright, I'm sure the owner will be pleased with that. Thanks for watching.